We were traveling through America and we came across this strip mall that had an import store. We went inside. My wife picked up a couple things, and I found this hourglass. Always wanted one of those brass hourglass jobbies, so I picked it up and it sat on my desk for about 6 months and till today. So here we go. Let's build one. We'll measure the diameter at just under 1 3/4. We're just drawing half the profile, so we'll set that radius, and then for cosmetics, we'll finish off the smallest diameter and the length of the straight sides. And throw in a couple of fillets. Then we'll mirror the whole thing over. Radius the inside. Set the overall length. We'll select the material. We'll call it glass. Save it out. Start on the base. Again, we'll just draw half the profile and revolve it. Just start with a rough sketch and then add in the dimensions, revolve it around. We're adding the counterbore in. Here we're drawing the 3 counterbores for the spindles. Rotate them 3 times, and then offset extrude cut them through, 100th thou off the bottom. Then we'll draw in the through holes, 3/16. It was a little close to the edge, so we moved it. Save that and bring in the other piece to start an assembly. Top and the bottom. Line up the holes concentric. And then we can measure the overall length that we'll need for our spindles. This will be another revolve, drawing just half the profile. Just playing around, trying to come up with something that looks nice, and then mirror it over again. Add the 100th thou spigots on the end. Clean up a couple of issues. Save that out and bring that into our assembly. We made it to the concentrics. We could see it was hitting the glass, and now we're just tightening up those radiuses. Looks okay there. And just to make the model complete, we'll copy out 2 more, place them. I didn't really like the look of these double bubble in the middle here, so we're going to change it to just 1 radius in the middle, and straight sides are tapered. Just pull a couple of dimensions off a drawing for the manual turning. And we'll bring in the base too, just to part off a couple of these to length. We bring the base into the CAM software, position it, put some wireframe geometry on all the edges. Setting up a counterboring operation for the middle. It ramps in nicely and then spirals out to the outside. And we'll do the 3 counterbore holes, ramp them down with a 1/4" end mill. Now we're going to drill out the 3/16 holes, spot them first. Set up the stock for the simulation, check it out. Looks like it's doing what we want. That hole's a little out. Figure out what's going on there. Still got a problem. So we'll go back here. When we put those holes in, they weren't concentric with the other ones. We'll fix that. Bring it back into the CAM software. Reposition it. And we still have our operations, so we'll just reassign the new geometry. Regenerate those. Run the simulation. Click OK. We'll generate some code. Now we're going to put a 3D path around the tapered face. Here we're creating a surface geometry to drive our tool. It's cleaner than going over all the holes. I was on the wrong plane, so we'll do it again vertically. That looks the direction we want. Pick the ball mill for that. Now we're doing a rough step over with a coarse spiral so we can leave some grooves in it just for a design. By changing the scallop height, we can tighten up those grooves. And that looks good. Oh, we didn't have a facing operation, so that'll skim the top off. Here I've got laying out the brass stock. Got my carbide 6-inch scale there. Just lop off a couple pieces. Real nice scale there, it just cuts right through. Chuck upper blank. Just snug it up. Here we've got a bearing on a stick. We'll just roll that up against the face, knock it into trues. Lock it down and skim the face. We just knock off the corner with a 45-degree chamfer tool. Here we've got just a slug in the chuck in the vertical milling machine. We're picking up the center of the chuck. And we'll pick up the face of the chuck, and then in the offsets we'll add our parallel thickness and the thickness of the finished part. We've got our blank set up, just tap it in, make sure the parallels are snug, not moving around. This is sped up a little bit, but normally we'd have the coolant running for the video, we left it off. This is just a facing pass. So we'll use a 3/8 mil to ramp to depth. And then spiral out to clean up our counterboard. We'll ramp down with a 1/4 inch to do our counterbore. And then spot drill the 3 locations. We're just spotting it with the drill. We didn't go through it, didn't want to hit the parallels or anything. We'll finish it on this drill finish. This is a 3/8 ball mill. Again, it's just spiraling around to the inside, leaving a spiral groove in it. There she is. Check the fit. Couldn't find my 1/8 to 1/4 inch split collet adapter for my mounted points, so I'm just turning one down on the collet lathe. A couple thou over a 1/4, so we just skim the outside. And we'll drill it out to 1/8 on the inside. Got a little lazy with the oil there, but we'll just part it off. Take it over to the vise, split it down the middle. Clean out the burrs. And that'll mount in this die grinder so we can make our profiling tool. With a real nice mounted point, not like the one that comes with your sister's Dremel. It's close to 3/8, same as the high-speed steel we're shaping. I roughed it out in the pedestal grinder, and then we're just cleaning it up with the mounted points. Got our 3/8 brass, we're just touching off the end and parting them to length. Flip them around, clean up the other end to finished length. Just measuring, touching the tool, and taking off the 10th thou that I needed. So 3/16 spigot, 100 thou long. Both ends. And the center drill for live center. Now we're plunging in with our form tool. End up with about 180 thou thickness. Swing our compound over 3 degrees. We're just plunging into the minor diameter with our, and then pulling it out with the compound by hand, just winding it back. Take it all in one shot. Now we're going to do the other side. It's sticking out a bit too far. It's protesting. We can hear the chatting like crazy, but the camera's running, so let's just go for it. Oh dear. So let's choke up on it, bring the center back in. And we'll try that again. Same thing, just plunge in and wind her back, cut it with the back side of the tool. These are nice polished inserts meant for aluminum and non-ferrous. There she is. We'll just give her a quick once over with a 400. Then with a 600. And a little Scotch-Brite with some paste. Here we're just going to give the base a little buff. Oh yeah, here I wanted to cut out a piece of cloth for the bottom, but it was just did not want to cut with that punch, so forget it. Just cut it out, old-fashioned way. Had some rubber, just put down some double-sided tape and thought I'd stick this rubber on the bottom of the base, but I think I'll take it off and put find some white felt for it. We've got some slip fit retaining compound to put it all together.
No, wrong one. That is that a white one.
White. Here, you put that one in. No, in this. Get it straight. Okay, put the glass in the middle.
Oh, that's kind
Not
of
yet.
cool.
Put the paper on top.
Is this kind of like the thing where it holds the quicksand?
Yeah. That's fine for this part.
Wow. Now you're going to take a picture of it, right? Ooh. Cool.
Just let that set for a bit. So there it is. Altogether, design and build was about 4 hours. Nice little piece. Keep it by the desk. When somebody's yapping too much, you just flip her over and say that's all you got. Thanks for watching. Have fun.